Now, we looked at solving very easy questions, but what about solving more complicated ones? Particularly ones that are quadratic. So let's take a look at a question like that. So sine squared plus 3 sine x minus 4 equals 0. Some people can see how to factor these straight away. If you struggle with this part, you might just want to take, you can see this as a squared, so just put x squared instead of sine squared. Instead of 3 sine x, just put 3x. And then go ahead and factor this one. So two numbers that times to make 4, subtract to make 3, that's going to be 4 and 1. And I need positive 4 and negative 1. Then after you've done that, just replace x with sine x, and you can indeed see that that's how we got to the answer. Once we've done this, if we've got two things that multiply to equal 0, either this one's 0 or this one is 0. So if we solve the first one first, bring the negative 4 to the other side, so it becomes negative 4. If you try doing inverse sine of negative 4, you'll get error. And the reason you'll get error is, if we go back to our sine graph, notice the lowest value we can have is negative 1. So we're not going to be allowed to have negative 4, so no solution to that question. The other answer is, when does sine x minus 1 equal 0? So when sine x equals 1. If we do inverse sine for that, we'll get 90 degrees. Or if we wanted it in radians, I've just written it as pi over 2. And you can actually see from the picture between 0 and 360, this is the only point where it actually equals 1. If we add 360 onto that to find the other value, it's 450, which is obviously much bigger than 360, if that is our range for that one. Or our domain, I should say. Same idea with this question, except there's an extra problem for this one. We've got two different trig ratios here. One is sine squared, but the other one is cosine. So we need to make sure that they're both the same trigonometric ratio. So I can use an identity. Sine squared plus cosine squared equals 1. Or if I rearrange that, sine squared equals 1 minus cosine squared. Now I can distribute. I can collect terms together. I don't want to factor with a negative here, so I'm going to times everything by negative 1. And then now I should be able to factor. So this is like doing 2x squared minus 5x plus 3. We used slide and glide in the previous class. So I'll just do a little reminder for that. So you multiply the 2 at the end to make this into 6. We then factor this, which is x minus 6, x plus 1. You've got to be a little careful with this one not to put 2 and 3, because 2 and 3 would make 5. Oh, I guess for this one that would be 2 and 3. Whoops. Minus 6 plus 1. That's not going to work. So let's try minus 3 and minus 2. Yeah. X minus 3, x minus 2. This time I do have to add the numbers together, so it is indeed 2 and 3, which gives me 5, and not 6 and 1, because that's if you subtract, which we're not doing for this question, because we're adding. So you've got to be very careful when you're doing this. As you can see, I just messed up too. Now remember, it's slide and divide, or slide and glide. I haven't done any dividing or gliding yet. As I originally multiplied by 2, I'm now going to divide by 2. Any simplifying you can do, 2 over 2 is 1. If it doesn't simplify, the number glides to the front. So we've got 2x minus 3, x minus 1, which hopefully is what I have here. Yep. Now we can solve each of these independently, equal to 0. So either the first one or the second one is 0. When does cosine x minus 1 equal 0? When cosine x equals 1, and then from the graph, 0 and 2 pi, or 0 and 360. And for our other one, when does cosine x equal positive 3 over 2? And of course it doesn't, because cosine goes between negative 1 and 1. So a little more complicated when the leading coefficient isn't 1, and also when they're different ratios. Our last one. 3 sine squared x plus 4 cosine x minus 5 equals 0. So I've got two different ratios again. So sine squared I can write as 1 minus cosine squared. I can distribute. I can rearrange. I've got the leading coefficient of negative again, so I'm going to times by negative 1 to get rid of that. And then I can try and factor this, and I can try doing slide and glide, but I'm going to have two numbers that times to make 6 and add to make 4, which is going to be a problem. So that's not an easy question to do, so actually we're going to need to do the quadratic formula. Find out what x is. Once you have your two x values, change the question to cosine x equals those two values, and then go ahead and use the method that we used for an earlier question. As you can see, this is a much longer question, And if you were to get a question like this for the AICE exam, then obviously this is going to be worth a lot of points because there's a lot of places that you could potentially make mistakes on. Alright, that should summarise all the things that we covered in AICE 1, and hopefully now you can go ahead and attempt the exercises for today's lesson.